Hello everyone, my name is Ryan Morales. Welcome to this video tutorial. Today we're going to be doing another problem on related rates. This time we have a sand clock. So our problem goes as follows. A sand clock is formed by two communicating glass cones, and each cone is 10 inches high and 5 inches in diameter. The sand inside the top cone is falling into the bottom cone at a rate of 3 cubic inches per minute. Find the rate of change of the height of the sand contained in the top cone of the clock when this height is 7 inches. Okay, so analyzing this problem, we can see that we have a sand clock, right? So it has a top glass and a bottom glass. The top glass cone has sand inside, and this sand is sliding away from the cone, meaning that this is a cone of glass and the sand inside has the same shape, so therefore it is a cone as well. And if this sand is sliding away, it means that the dimensions of this cone, overall dimensions, are shrinking, so the volume is shrinking, and that implies that the radius is shrinking and the height is shrinking. Now, they give us the following information. The height of the glass cone is 10 and the diameter is 5, and they ask you,
when the height of the sand is exactly 7 inches, how fast is the sand, or
the height of the sand, changing with respect to time? Now they give you also the following information. The sand is sliding away at a rate of 3 cubic inches per minute. Okay, now this is actually the volume that is sliding away from the top cone. So this is the rate of change of the volume of the top cone, which is dV over dt equals, and this is negative because it's shrinking, the volume is shrinking. Now, we know that we need an equation that relates the information they give you with the information that they're asking for. So this equation, I'm going to write it here from geometry, is the volume of this of the cone, which is volume of the cone equals a third pi times r squared times height. Now, this equation has three variables: volume, radius, and height, and we only have information about the volume, and we're looking for the height. Okay, so let me write here what we're looking for. We're looking for the rate of change of the height with respect to time. Alright? When the height is exactly, write this, when the height is exactly 7 inches. Okay? Now, to change, to get rid of this radius in this equation, we're going to make use of the following fact. Since the sand is inside the glass, it has the same shape. Therefore, the proportion of the sand cone have to be similar or equal to the proportions of the glass cone, meaning that the radius of the sand over the height of the sand, and I'm going to write it here, so radius of the sand over height of the sand have to be the same as the radius of the glass, which is 5 over 2 divided by 10, which is the height. 5 over 2 because we're looking for the radius, and 5 radius, and 5 is the diameter. Okay, so if you simplify this equation, this will be 5 over 20, which is equal to a fourth. Alright, so I'm going to go ahead and solving for r from this equation. This will be, let me just rewrite this, r over h will be 1/4, therefore r will be a fourth, 1/4 of the height. Okay? Now, what I'm going to do is I'm going to replace r by this new expression in this formula, and I'm going to go ahead and do it here to have more space. So what I'm going to say is, let me use a different marker. So volume now, is going to be equal to a third of pi times r squared. Now r squared will be this thing here squared. So a fourth of the height squared times the height. Alright, now let's go ahead and simplify this. We have to square everybody inside the parentheses. So volume is going to be a third of pi times 1 over 16 times height squared times height. Okay, if you simplify this, this will be 3 times 16 is 48. So volume equals, I'm going to write pi over 48 times h cubed. Why? Because this h squared times h is equal to h cubed. Now, this equation here is the one that we're going to use to do implicit differentiation and find our rates of change. So, let me change colors again. I'm going to do the implicit differentiation of this whole thing here. So, deriving the volume, that will give you dv over dt. You just draw a line here, not to get confused. So dv over dt is going to be equal to, this is a constant, so you just leave it there. Alright? Then this, how you find the derivative? You take 3 down, right? Reduce 1 in the exponent, times the derivative of the height with respect to time. Alright, so now I have this. I'm going to go ahead and simplify this so that it looks a little bit, okay, I'm going to simplify 3 and 48. 3 over 48 simplified to 1 over 16. So dv over dt equals 3 pi, not 3 pi, pi over 16 times h squared times derivative of the height with respect to time. Okay? So now, this equation here, we know what the value for height is. It's 7, and we know this as well. Okay? So we are looking for this. So all we need to do now is replace these two values and then solve for derivative of the height with respect to time. So we know that the volume has a value of -3. So -3, not the volume, the rate of change of the volume. -3, this is cubic inches per minute, but we're not going to write it here. In the end, we're going to put the units to the result. So -3 equals pi over 16 times the height squared. Now the height I know is 7, so 7 squared would be 49. 49 times derivative of the height over derivative of time. Now, all I need to do now is just simplify this. So how can I simplify? I need to get rid of this whole thing and send it over to this side. So I'm going to divide. Okay, I'm going to use the other side of the board now. So let me just copy this here. So -3 equals, and I'm going to write this as 49 pi over 16 times the derivative of the height with respect to time. Okay? Now, all I need to do to simplify this is multiply by 16, right? 16 on both sides, and then divide by 49 pi, which is 49 pi here. Divide 49 pi. Now, 16 and 16 would cancel. 49 pi and 49 pi would cancel. And this would be -48 over 49 pi equals dH over dt. Alright, now if you plug that into your calculator, this will come up to be -0.31 right? This number, and this is dH over dt. And this is our actual final answer. Now, I'm going to write it as the rate of change of height with respect to time is equal to negative 0.31 inches per minute. Why? Because this is height changing with respect to time. The height is measured in inches and the time is measured in minutes. That's why our units would be inches per minute. That's our final answer to the problem. Thank you very much for watching, and I hope you understood. If you have any questions, please, you can leave it in the comments, and see you next time.